Hey, how are you?
Good morning. Can you hear me?
Yeah, I can hear you okay. It's good.
Okay. Okay. So after a long time, we meet again. So you can continuously talk in my WhatsApp for doing your progress about your work. So now I will show you that work, what I do for you, and also show you some result. So basically, it's a remote sensing technique to identify for the mineral. Okay, so it can be different types of mineral, such as it can be iron oxide or sulfate or different types of or carbonate. Okay, so this type of mineral, as well as also deposition of hydroximal. So these type of things you can easily access using the different types of remote sensing technique. Okay, so I will show you the result, then it is more better. So let me try to share my screen.
Okay.
Can you see my screen now?
Yeah, I can see it.
Okay.
Yeah.
Yeah. Okay, so basically in this time, this is the region for your study area, and this study area near to the coast, mainly coastal land. So that's why it has a lot of cloud. You can find out this type of cloud. So basically, it's a cloud pixel for this study area. But some place we can also get the clear. So you can see this type of reason issue about the clear imagery about that. Suppose in this time, here I apply the different types of remote sensing technique and then extract the different types of mineral. Okay, so let's go try one by one. So basically here you can see it's called the true color composite. So basically when I use the band combination, suppose I simply put in here and I try to add the false color composite. Suppose I put here the near infrared band, then put here the and then put here that blue band and custom increasing stressing 98% and further apply it. So now we can get that false color composite. So basically we can get this type of things. So basically in this time, here we find out the vegetation, mainly different types of trees. Trees show this type of red color. Okay, this type of red color identify about the trees, as well as also water show as a black color. So it's the water body. It show the black color. And okay, but in this time we want to find out the rock index. So basically rock we want to find out from here. So for that I try to open the rock index map, then we can easily identify for the different types of rock. Okay, for this study area. Okay, so let me check where we find out the rock. Okay, it shows this type of result, but when I just click on here and then I can easily get the result for rock alternation, just by simply increasing 98%. And further just try to the apply provide me this type of result. Here you can see. Okay, and I want to add the some color plated, it also more better for visualization about the rock. So I want to show some of this type of color. For that there is no rock, and greater than I want to show suppose this type of green color. Okay, so green color. Further I try to apply suppose this type of red color, and for the high positive value I want to show this type of yellow color. So basically it's a concentration of the high rock. So just I try to apply it. Okay, so now further after applying this rock index, here we find out this type of things. Here you can see basically this type of yellow color, it's identify about that rock. Okay, so it can be different types of rock. So basically for the gold or any other kinds of mineral, it the store it in that the rock. Okay, so different types of rock, when we can mainly we find out that different types of mineral. Okay, so here you can see we find out this type of result. So this type of yellow color, I see also more zoom, then it's more better. And also try to open this base map as a satellite. Load it, just so in this time here you can see we can get this type of yellow color. Okay, so basically this yellow color, it cannot be vegetation, it cannot be water body or anything, it just can be the rock or different types of soil carbonate or any kinds of mineral. Okay, so it's stored the different types of mineral, it can be stored. So now further from here we find out the some specific mineral. Suppose rock alternation, we try to find out that rock alternation place. So let's check about the layer what we can get from here. For the rock alternation, it show that this type of totally white color. So I want to set the suppose I want to set here that visualization parameter for rock alternation, and I try to put here stressing at 98% stressing, and further try to apply. Right. So now we can get this type of rock alternation. Okay, so just I try to add the color, then it's so more better understand. Suppose I put at this low value for that, get at then value and to show suppose this type of green color, get at then to show suppose red color, and high positive value and to show this type of yellow color. Okay, and then try to apply it. So now we find out that rock alternation. So here you can see it look more better now. Yeah, so basically here you can see this type of pixel. Here you can see this type of yellow color pixel, it mention about the rock alternation. Mainly it can be rock, this rock is the alternative. Okay, it can be, so actually there are a lot of process for rock alternation. It can be wind process or water process or different types of factor influencing on the rock alternation. And in this time, from this map, we find out the rock alternation. Here you can see, we find out that it's a one kind of rock alternation. Also, this type of things is the rock alternation about that. Okay, we can find out from here. So this type of place is a rock alternation about that. Not only for that, if you want to check the what's the specific location, suppose I just suppose click on the inspector tab, and I just try to click on this. Suppose I just click on here, I have to check about that specific geolocation, mainly GPS location. Just click on here. So now it provide me this geolocation. Okay, so this is the point. This point I find out the rock alternation. Suppose it show about that it is a longitude value and it's a latitude value. Okay, longitude value, this is the longitude value. It show the result in the your decimal value. Okay, you can see it's the longitude value and it show about the latitude value. Okay, so further anyone, they simply open their GPS tracker or GPS machine and then go to this location. Okay, suppose when you put this longitude latitude in your GPS machine, it automatically located your study area. It automatically located in your study area, and from here you can simply go to this region, and then further you try to observe this area. What's the condition at present now about this?
Sure.
Okay. So this is the rock alternation. Further, suppose I will try to more another one. Suppose in this time, I just try to open that. It's another way for hydrothermally alternate areas. Suppose I try to open it. it shows this type of thing. But when I want to add the color plated and just stressing 8%, and I try to add the apply. In this step we can find out the hydrothermally altered areas. So further I just try to add the color. Suppose I already show about that. I put this type of blue color, and then further later then I to show this type of green color. Later then I to show suppose this type of yellow color, and further I want to show here suppose this type of yellow color for high concentration of the hydrothermally altered areas visualization. I show that. So now try to open. Okay, so now we can get this type of pixel. Here you can see it show about this type of region about the hydrothermally alternate areas. And not only for that, if you want to check about this paper, suppose scientific paper, it also more convenient. Suppose I simply search on paper, suppose mineral exploration using Lancet 8. I simply search on the Google. Then further I try to open this paper.
It's not from ResearchGate.
Yeah.
Is it from ResearchGate?
Okay, let me try open from here. Yeah. So here you can see this is the one kind of paper. So mainly this paper they are used at the image ratio. Okay, to identify for the different types of mineral. Mainly they are used at the image ratios technique. So here you can see this is the paper about that. So here you can see, yeah,
we saw that one.
Yeah, so here you can see mainly mineral operators. So basically this is the formula about that. Here you can see rock index. Okay, also you can see about that hydrothermal alternate areas. Okay, you can see about that. Also you can see the rock alternation, hydrothermal alternate areas, and iron oxide, hydroximal bearing mineral. Okay, so this type of things we can generate from here. Further, suppose okay, let me show you the another layer. Suppose I want to open this iron oxide and hydroximal bearing mineral. Just try to open this layer. It look like that. I want to add the visualization. And further stressing 98%.
It's always 98%. You don't go 100.
Okay, so basically stressing 98%, it provide the better visualization. Okay, mainly 100% it show extreme, and 98 is the middle stage for that visualization. Okay, so further we are also get the better visualization about that. So now I try to add here. Suppose I want to show suppose this type of color for the low. Then I try to put here the suppose get at that green color. Get at then I put here suppose red color, and for that yellow I want to put in here, and then further apply it. So now it provide that iron oxide and hydroximal bearing mineral. So basically you can see this type of region. Okay, it show the high concentration yellow color. It show the high concentration about that iron oxide hydroximal bearing mineral. Okay, suppose in this time how we can easily work with your field. Suppose you can get the data from here. Further this data you have to use on your GPS machine or GPS locator you can put in here. So in this time you can just suppose you can simply click on here, and further you can simply take the some training sample. Suppose I just click on here. Okay, this is my one suppose one hot spot. So it called the hot spot. suppose this hotspot, when I find out, then I can get something. Okay, so this may one kind of hotspot. So you can simply put this point. Suppose this is my another hotspot, or you can take the mode. There is no problem. Suppose for the one region. Also you can see. So just suppose this is another hotspot. Okay, so you can take the some your hotspot. This spot you want to explore. Okay, so you can simply take some hotspot. So just suppose I take the total 5 hotspot. Okay, so now further this total 5 hotspot I want to export as a KML file. Okay, suppose I simply export. I feel that I put it's my point, it's my hotspot. Basically we can put any name. So it's my hotspot. So this hotspot I can find out something. It can be mineral, different types of mineral, hydroxymal bearing mineral, or it can be different types of things. I can must find it here because it shows about that highly concentration about that iron oxide or hydroxymal bearing mineral. It's the high concentration, this type of color. So I simply put some total 5 point. So now what can I do for my field? So after getting this point, I just simply export it as a KML file. Suppose I just simply export dot table to drive and full all of things one by one. I will show you this whole process. Just a minute. I just simply make a dictionary. And you can use the one code you can easily use. Okay, suppose when I provide you this code, you can easily use this code for the different location, and you can also explore one by one what happened. So first of all, location. Suppose in this time I simply put here the hotspot. Okay, just I take a variable, suppose collection, and then put here te dot feature collection, and further I put here that hotspot. Okay, so this my collection. I simply copy and paste here. This, then put here the description. I put the description. It's a mineral. You can put any name, no problem. I put the folder. Suppose folder is that G. File did not need, remove that. Then file format. I put the file format is that KML. Okay, basically KML file we can easily use to locate our place. So just I show you that how it will work. Click to the run, and further I click on the task tab, and now I just simply click on the run button. Here you can see it show the run. Just click on here, and you can see the format is the KML file format. Okay, KML file format, and further run it. So now this, it will be takes 1 minute time. Then we can easily open it in our Google Earth. Okay, because Google Earth is the very high configuration for accessing the different types of object. Okay, then we can easily open it in our Google Earth, and then go to our field and explore. Okay, suppose in Google Earth we can easily open the live location. Okay, suppose I simply open in Drive and download this. Not download it, so I simply search here Pro. So this is the software. It also supported the mobile also, Google Earth Pro, and also supported the computer, also web version you can see, or Google Earth on mobile or desktop. So just you can simply open this. I simply open the web version. Okay, now it open Google Earth. It's high configuration. We can easily find out that different types of object or other things. And this software is also supported the KML file. Okay, so this KML file I downloaded. This KML file is automatically supported in the Google Earth Pro. So you can see it look like that. So from here you can simply click on the file option, and then go. You can see the import KML and import. It's working. and further go to the download folder and I try to, okay, so you can see the KML file. I simply import this file. So now it directly open my study area. You can see I can get it. Look like that. Okay. Okay. Okay, so you can see it show this type of location. Okay, you can easily simply go to this study area and then try to explore it, what we can get. Okay, so basically it's when you want to go this point, you have to check the 30 meter. Suppose if this is the middle center about this point, you can go to the 30 meter and also go to the 30 meter. So you want to make the 30 meter square. Okay, because in this time we're using the Landsat imagery. Okay, and Landsat imagery pixel size is the 30 meter. Suppose you go to this point and explore the 30 meter area. 30 meter area as a box, you try to explore it, what happened, you can get anything or not. 30 meter area, as well as also go to this, suppose you can simply go to this another location, simply go to this location and you try to find out here 30 meter, because it's a Landsat imagery, this resolution is a 30 meter, so that's why you try to cover the 30 meter study area and then check what happened for this study area. And you can easily open this file in your phone. KML file is also supported in your phone. Just you have to install the Google Art Pro. Okay, and then you can simply open your live location and also check your point. Then you can easily get, make this type of result, what happened in this 30 meter area. Okay, so basically for the gold mining or also other types of mineral, we have to use this type of technique. First of all, you need to explore or find out the high density. Suppose where I find out the high density, so this is my point, this is my hot spot. Further, this hot spot I want to convert as a point, and then I simply go to the field and check overall all of place for the 30 meter. When I use the Landsat, I want to check the 30 meter square area for this point, all of area, and then try to explore what happened. Okay.
So, my question is,
Yeah, please.
would it be able to go ahead detect buried metals with very high mineralization, like precious metals like gold, something like that? For example, it has been buried for 60 years. Would that be an altercation on the ground?
Okay, so for the underground, for that we have to find out that surface condition. Okay, suppose it will be alternate or what's the situation on the surface. Okay,
Okay.
then
So
go to the underground and then check about that.
is that possible on the program that you created?
Okay, so basically remote sensing, this technique is only possible to the surface, not for the go to the surface. So for the surface condition, we consider the underground. Suppose for the surface, I find out that lot of alternated mineral. I find out the lot of different types of mineral. Then we consider that this surface, this underground, we find out something. Okay, suppose when I find out the something on our surface, so according to this condition we can take the decision, the surface we might have get something for the remote sensing.
But is it okay if we go and put it to the test if we could get something? I have two spots here wherein these are Japanese camps wherein they buried like tons of gold, and I don't know if it would come up as an altercation on the Google Map or this Google Earth engine. Is it okay if I give you a spot or a coordinate and let's try it out? Would that be okay?
Yeah, so in this
Okay.
time, okay, so first of all you try to explore the hotspot. Okay, so using the remote sensing we find out the some hotspot region. Further we simply visited this region and then check what happened for the physically or field survey.
Yeah. Let's try that. I'll give you a sample area. I'll go ahead and send it. Just give me a few sec. This is a very easy one. I'm going to send you the information in WhatsApp.
Okay,
That's
you can
the,
send me. Yeah.
that's the coordinate.
Okay, so this is the coordinate. Okay, let me check. Okay, so I just try to open it in Google Earth engine. So in this time, simply put here this 124 point. Okay, can you send me it in your Google Meet inbox? It also
All right.
better. Yeah, yeah.
Sure. No
Send,
worries.
just like copy and paste.
The other guy I'm speaking with in Myanmar is a geologist. He's using Envy. He's doing raster.
Is it raster?
Yeah, so raster, and then he would combine the bands, and like it's like he's putting layers on it, and it would show the area where there's anomaly. I actually sent you the video of that. It's very interesting, but he's not using Google Earth Engine. It's using a different one.
Yes, coordinate. Yeah, got it. Yeah. Okay, so this is our study area. Suppose, yeah. Suppose in this time it look like that. This is your study area. I want to
Yes.
take suppose 10 kilometer, mainly 10,000 meter. I want to cover this whole study area, and then try to check from here what we can get. Suppose this is our study area.
Yes.
Okay, and it also clip with our RY. So just like clip with our this circle boundary. Oh, right. Check. Okay. You can observe only for this study area, but here we find out some cloud. Okay. Mm. Now I try to add, suppose one by one I try to add the layer. You can see these are imagery.
Yes.
This imagery it shows some cloudy pixel. Okay, we try to ignore the cloud. Testing 98%.
Right.
Further apply. So now we can get this type of place. So basically, this type of is the cloud. Okay, and otherwise we can get this type of things here. You can see it's the water body vegetation. So this type of things we can easily get from here. Okay, so and also try to rock index what happened for the rock, and further put here. So you can get this type of rock index. So actually this is our cloud. So cloud. So it showed up. Okay, so I want to add the color and check what happens. Suppose I put add the blue color for that, and then get it, then put add the green. Suppose I put add that yellow, and further put add that yellow. Okay, so you will show the high concentration of the rock. So now apply. Okay, so now from here we find out this type of region. Here you can see this type of region show about the high concentration about that rock index, mainly mineral. Okay, so basically you can see we can get some also this type of pixel. Okay, pixel, but it show about the cloud. Okay, it's a cloud. Okay, yeah, it's not concerned about the, but in this time we can get the rock. Rock is show about this type of place. It show about the rock. So further we try to show the another layer. Suppose rock alternation. It look like that. I try to export here stressing, and further open this layer, rock alternation layer. The stressing, and further apply it. So now I can get the rock alternation. This type of region is the rock alternation. I want to add here, suppose it's low density about the rock recognition. Then get it, then I want to show suppose this type of green. Get it, then I show suppose this type of yellow. And high concentration about the rock alternation, it shows about this type of yellow color, and further I try to apply. So now we can get that rock alternation. Here you can see, so basically in this time it show you this type of place. Okay, this type of yellow color place, it show about the high concentration about the rock alternation. Okay, and further I want to show the another layer. Suppose hydrothermally altered areas. Just click on here.
So the hydrothermally altered areas.
It's one kind of mineral with mineral bearing from the hydro. Hydro means water, flow of water. Suppose some region you find out for the river or coastal land, we find out in the river bank or coastal bank, we find out the some different types of mineral. Suppose it the flow of water, it coming some mineral. Suppose
So
yeah.
it could go that deep.
Yeah, and if it's the, suppose some region for the rainfall, rainfall or precipitation when occurred, then some mineral also flow the water body. Okay, the flow of water, the mineral is also flow with the water. So it's called the hydrothermally altered areas. So in this time when I open this layer, it indicating the hydrothermally altered areas. Suppose I try to show you that. Suppose I want to just stretch 98% for better visualization. Suppose I want to show, suppose low area, I want to show the red color. Suppose greater than, I put at the yellow color. Suppose greater than, I put at this green color. And high, I want to show this blue color. Suppose in this time blue color show the this type of altered for hydrothermally altered areas. So basically it means that it bearing the mineral flow of water. Okay, so like I try to show you that what happened for that. So here you can see this type of blue color. So blue is the high concentration. So this type of blue color identify about that hydrothermally altered areas. It means that the flow of water, this flow can be created different way, precipitation, rainfall, or any other way to generate this flow. The flow of water making this type of mineral altered, hydrothermal altered areas. Suppose this type of region, it can be flow some mineral. Okay, so it's called the hydrothermal altered areas. As well as also you can see about the iron oxide. Iron oxide mainly different types of iron or hydroximal bearing mineral. Hydroximal bearing mineral means that this mineral bear the hydroximal. So just I try to add the thing. Suppose just click on here. And further stretching 98% and add the plated. Suppose I have to put for, I have to suppose low, so this type of blue color, then greater than I have to show suppose this type of green color. For that I have to show suppose this type of paste color. Suppose I have to show for that yellow color. For the high hydrogen oxide, show the red color. So you can choose any color combination, it's not problem. In this type, red color identify about the high concentration about the iron oxide and also hydroximal bearing mineral. Suppose I click the apply. So now let's check what happened. Yeah. So you can see we find out this type of iron oxide. Suppose in this time, this type of region, here you can see this type of red color. Okay, only for the red color. Red color. So this type of region, it show about that iron oxide and also hydroximal bearing mineral type of region. Okay, and now you want to simply survey, go to the field and you try to check what happened in this type of red color region. Okay, so for that same process, just simply take the point. Suppose in this time for your study area you want to visit it. After checking the remote sensing technique, now you ready to go to the field. So what you can do, you can simply take the some point. Suppose click on here, you take the 1 point. Suppose just click on here. So you can take the some training point, look like that. Okay, and further this training point, you just simply export as a KML file or KMZ file. Then open it on your mobile phone or your device, and then you can simply check your study area physically what happened. Okay, so you can easily upload these things in your Google Earth Pro, and further you can go to the visited. Okay, because Google Earth Pro is also supported the live tracking. You can simply open it in your live location, and you can also add the layer of the KML file, and then directly you can visit your study area. Okay, so basically this is the process, one process for mineral exploration. Actually there are a lot of process for mineral exploration, such as gold or also hydroximal bearing or iron oxide. There are a lot of way. So it's one kind of basic way to monitor the gold or mineral or hydroximal bearing mineral or iron oxide or rock. So these type of things we have to use for that. But it also other lot of advanced model is also available. Suppose you want to find out that mineral exploration using SAR images, mainly it's the Sentinel-1 satellite imagery. For the SAR images, we can also use to monitor, detect the mineral. It's also possible for the SAR imagery. As well as if you want, you can also use the different types of machine learning or deep learning to detect the gold or mineral. It actually there is no limitation. There is a lot of process to do it. So and it's very easy way because anyone can easily detect the place using this technique. Just you can simply draw your hotspot and then take some training sample point and go to the physically visited your area. You can just locate at what happened for this study area.
Can you check if that area I sent you has a anomaly?
Yeah. So which area basically instead of this area, yeah, this coordinate you want to check, yeah. So for this
Yeah.
coordinate, yeah. So in this time, this is our coordinate, and we take the mainly 10,000 meter, mainly 10,000 kilometer. You can see. I will show you the code. Yeah. So actually, this is your study area which you send me, and if you want to check it, suppose I will show you that. I just put here this study area. Suppose I put here that 1 meter buffer, 1 meter, mainly 1 meter, and then try to check what happened. Then this is your point. This point, make the 1 meter area and get the result. So just I try to open it from here. Okay. And I also try to click with 1 meter area. It show about the 1 meter result, but first time it show about that 1,000 meter. Okay, let me check. Okay, I have to put here this was 30 meter because our satellite meter is 30 meter. I try to put here 30 meter. Okay, let me check. I put the 300 meter buffering.
Do you have to change the one
So
to
this is the study area you can get here. You can see. Okay, so this is your exact location he will send me. And now I try to visualize this. Yeah, so this is the location which you send me.
Yes.
Okay, so now I try to add here, suppose all of visualization one by one. Suppose rock index we try to find out. I just increasing it, stressing 98%. Further I try to apply. Okay, I just try to add the color of rock. Suppose slow it show about this type of color. Then get it, then it show this type of color. For that it show this type of yellow color. For the red color to show for the high concentration about that. And apply. Get loaded. Yeah. So here you can see we can get this type of rock index. So basically for this study area, we'll find out this type of region. Here you can see. Yeah. So it show this type of color. So each this place it show for the high concentration for that mineral. This place. It's also possibility for this type of yellow color. You can see it also available for the yellow color. So it's that another chance to get the rock. Okay, suppose I want to put that rock called I don't know, I try to open this final layer, iron oxide. and then try to find out the what's condition about that. Stressing 98%, and further I try to plate it. Suppose for that, for the low I need to show this type of color, and then get it, then I need to show suppose this type of green color. For that I need to show this type of yellow color, and further I need to show suppose this type of yellow color, and further I try to apply it.
Are you there?
Okay, just when I can connect the another net. Okay, so now it's okay. Yeah. So okay, let me check. So now we check about the iron oxide and hydroxymal bearing mineral. So just I try to put in here. It working? Just a minute. I face some networking issue. Just a minute. Or networking issue. Yeah. Load it. Bearing mineral. Okay, now run me the code again. Show the networking issue. Now I try to open it from here and then try to check the final for iron oxide and hydroxymal bearing mineral what's happened for this study area. And I try to add the color plated from here. So just for the low I want to show this type of blue color. Get it, then I want to show this type of yellow color. Get it, then I want to show suppose this type of red color. And finally for that I want to show suppose yellow color. And then further okay and apply. So now try to check about that. Yeah, so now we can get this type of result. Here you can see. Okay, so in this time we can get this type of place. Here you can see it is the high concentration to get the mineral. Also you can see this type of region, this type of region. Actually it's not a small region, it shows the 30-meter pixel. So this square, it's a 30-meter square area covered. Suppose this yellow color, it shows the 30-meter square area because it's the Landsat imagery. Landsat image is a 30-meter pixel size. Okay, when you want to explore, you can simply take the location from here. Suppose you take the point or take the then simply import the Google Earth Pro, and then you try to cover the 30-meter square area, whole 30-meter area. This pixel mainly 30-meter square pixel, and you want to find out this mineral within this 30-meter pixel area. Okay, I hope you can got this idea how it will work. So basically in this time you have to know how we can easily use this code. Okay, further you try to explore the different region and then you try to check what happened for that.